Okay, so in this problem, we're looking for the solution set. Those two numbers are given there, so we have to solve for this. To isolate the variable, we just have to divide this by 6. So we get 2 minus 1/3 x is equal to 3. Create the two equations, 2 minus 1/3 x equals 3, and the other one, 2 minus 1/3 x equals negative 3. Then we solve. So take away 2. We'll have negative 1/3 x is equal to 1. And then again, to eliminate the fraction, we can divide it by the fraction or just multiply by the reciprocal. So reciprocal of this is negative 3 over 1. So multiply both sides by negative 3 over 1. That actually eliminates this as it becomes 1. So x is equal to negative 3. So that's one of the possible solutions. I try it on here. So take away negative 2. We get negative 1/3 x equals negative 5. Multiplying both sides by negative 3 over 1. And we will get x equals positive 15. So those are the two answers. So we have C. Okay, for this problem, it's just note that when we graph inequalities, everything in the shaded area means it is a solution to the problem. If you look here, we're just looking for a reasonable solution. So we graph each one and see if it qualifies for all the conditions given in the problem. What are the conditions? At least 10 more bracelets. There are at least 10 more bracelets than necklaces. And second, it fits in the shadow in the shaded part of the graph. Number one, we can't use that as we don't have 10 more bracelets than necklaces. Now, letter B is possible because 30 and 15, that's more than 10. 40 and 20 for letter C is good. But letter D, we have bracelets are less than the necklaces. So we only have B and C as possible solutions. So we graph each one of them. So 30 bracelets, that's over here. 15 necklaces is over here. So we figure out where they meet, and it's over here. Okay, so, oh, it's within or inside the shaded part, so it's a solution. Now let's look at C. Why is it not a solution? 40 bracelets is over here, and 20 necklaces is over here. If we see where they meet, it is here outside of the graph. So it is not a solution, so only B is the final answer. Okay, for this problem, we know that the three equations or inequalities are the same. The only difference is whether they are greater than or less than. So first thing that we can look at is their slope and y-intercept. So 3 halves x plus 4 will be this line. Y-intercept is 4 and goes up 3 across by 2. 0.3x minus 3 will be over here. You know that the y-intercept is minus 3 and that's the only one there. So this is the 0.3x minus 3. And then this one is negative 2x plus 3 because we can see from the graph the y-intercept is 3 and also that it has a negative slope, it's falling down. So one of the things you'll notice is negative 2x plus 3 has a solid line. So this must either have a less than or equal to or a greater than or equal to. So looking at this one, just by looking at that one, you already notice that A is the only possible answers because the others don't have the equal sign with them. But just in case, I just want you to figure out why that's the answer. So less than negative 2x plus 3 is the region, this, or that, those regions, the ones I mark with a red dot. Okay, now if I look at greater than 0.3x minus 3, so it's over here, anything above it, so that's the one I mark with green. And then for 3 have x minus plus 4, it's less than that line. So below that line are anything I marked in blue. And looking at the graph, the shaded part is where the three of them meet, and that's what A does. So it matches what A has in its conditions. To be able to solve these systems of inequalities, so it will be good to know how to graph these inequalities as a line first, and then figure out if it has to be solid, dashed, or where the shading should be. So there are three equations here, or inequalities. So if you look at this first one, it has a y-intercept of positive 3. So that represents the y equals x plus 3. And then this line has a y-intercept of 0. So that means this one is represented by y equals negative 4/5 x. And then the last line has a y-intercept of negative 3. So that has the line y equals 5x minus 3. And knowing from the graph, the y is less than or equal, so negative 4/5 x has a dashed line. Therefore, it's either less than or greater than. Since the shaded part is above that line, so we can say that this is greater than. Next, if we look at the y equals 5x minus 3, it's a solid line, so that will be a as an equal, less than or equal to, or greater than or equal to. But then if you look at the shaded part in relation to that line, it's at this shaded part is below it, so this will be less than or equal to. And then for the y equals x plus 3, it's a solid, it's a dashed line. Therefore, we will have either less than or greater than. And as you can look at the shaded part, it's below the line, so it's less than x plus 3. So looking at that, we will have the final answer to be y is less than or equal to 5x minus 3, which is this one. And then it should be greater than negative 4/5 x. So it's where this one is. And then it's below the x plus 3. So it's this one. So B has all of these lines in its in this choice. So the answer is